Good morning. Today we are covering section 2.7, use absolute value functions. We are graphing absolute value functions, and we're also going to be describing the transformation depending on the values of a, h, and k. First, let's look at the concept of absolute value functions. As we learned before, the absolute value of x can be described in three different ways. If x is positive, then the value will be itself. If x is 0, it will be 0. If x is negative, then the value will be the opposite. If we have a graph, and we are going to be working with a linear equation, this is the equation of y is equal to x. If we take the absolute value of this function, instead of just y is equal to x, y is equal to the absolute value of x, what happens is that all the negative values become the opposite, so they become positive. So this is the graph of an absolute value function. If you notice, it creates a V. All the positive values remain positive, 0 remains 0, but all the negative values become the opposite, which will be positive as well. We have, on the right hand side, if it's positive, your V, your absolute value will be facing up. If it's negative, your absolute value will be facing down. If you guys have an example, if it's the value of A is positive, then your graph will be facing up. If the value of A is negative, your graph will be facing down. Let's look at the equation. So we have, this is the equation of an absolute value function. Y is equal to A, absolute value of x minus h plus k, where A, it will determine how wide it opens and whether it's facing up or down. H and k will correspond to the vertex. Now, because this is x minus h, that means that the value of h is the opposite of what's here. For example, number 1. First thing, we need to be able to find the vertex. The vertex is 1, 2. Remember that your value of h, because the formula says x minus h, the value of h is the opposite, so it'll be positive 1, k will be 2. Let's go and plot it. 1, 2, 1, 2, it's up here. We are going to draw the line of symmetry. It's going to be a dashed line. The equation of this line is crossing the x-axis at 1, so the equation will be x is equal to 1. Now we need to be able to find other points on the graph. Because this comes from a linear equation, we still have my slope to be 3. This will be the value of a will be your slope, 3 over 1. So I'll go up 3 and to the right 1. I'm going to use my axis of symmetry to be able to find the other point on the other side. And then I'm just going to connect those 3 points. I'll connect the vertex with each of those points. And that will be my graph. Now below it says, describe the transformation compared to 2 absolute value of x plus 1 minus 3. So I want you we're going to be comparing two aspects. We're going to compare the translation and the transformation. First, let's go and do the translation. We're going to find the vertex for this to be -1, -3. And we are going to plot it. -1 and then -3. That'll be the vertex. We need to be able to find the transformation. So that was -1, -3. So first we need to be able to find the vertex, which is -1, -3. We're going to plot it, -1, -3. And we need to be able to find the transformation. We need to go from the f of x to g of x. To go from this vertex to the other vertex, we're going to go to the left 2 and down 2, 4, 5. So from f of x to g of x will be left 2 and down 5. Now that transformation, we need to decide whether it's wider or narrow. We are going to plot the slope, so up 2 and to the right 1. And we're going to do the mirror using the axis of symmetry. We're going to do the other point. We're just going to make a little quick sketch. So we need to decide which one's narrow and which one's wider. Now, if you're not sure, we can also do the 2 over 1 here. If you notice, if we had done 2 over 1, the red one, g of x, is wider than f of x. Or we can say that f of x is narrower than g of x. Let's continue with example number 2. On example number 2, we are going to go through the same process. We're first going to be able to find our vertex. Our vertex is -2. Remember h, because of the formula, h is the opposite. K is -3. That'll be -2, -3 is my vertex. I'm now going to draw my line of symmetry. The line of symmetry is crossing the x-axis at -2, so the equation is x is equal to -2. I need to use the slope to be able to find other points on this function. My slope is 2 over 3, positive 2 over 3. So I'll go up 2 and to the right 3. I'm going to repeat it once again, up 2 and to the right 3. I'm going to go on to the other side. I'm going to use my line of symmetry to be able to find my other point. This point is 1, 2, 3 units away from that line of symmetry. I'm going to go 1, 2, 3 to the other side. I'm going to connect my points. And we have our graph. Now I need to be able to describe the transformation compared to g of x. So first I'm going to find my vertex for this new g of x function. So we have 2, 4. So 2, 4 is up here. And let me just go and graph it. So I'm going to go, my slope will be -3 over 1. So I'm going to go down 3 and to the right 1. Down 3 to the right. Just going to make a quick sketch. Remember, the red one is the g of x. Now let's go and describe that transformation first, or the translation. I'm going to move f of x over to g of x. So I'm going to go to the right 1, 2, 3, 4. So I'm going to move f of x to g of x. So I'm going to go to the right 4, and I'm going to go up 2, 4, 6, 7. That is the translation. Now I'm going to see which is narrower or wider. I'm going to compare f of x to g of x, and if you notice, this is very easy to tell. I know that f of x is wider than g of x.